Today's goal is to solve basic radical equations algebraically. Algebraically means not graphically and not using your calculator. And to solve means we're looking for the solution, the x values that make the equation true. We're solving different kinds of equations than what we've seen so far. Radical means it's got a square root or a cube root or something like that. Okay, let's take a look at our first example. To solve this equation, we can start by adding 5 to both sides. We get root 2x plus 1 equals 3. And now that we have the square root all by itself, if we square both sides, squaring and square root are inverse operations, so we can think about them as canceling each other out. So we end up with a linear equation from here. Let's double check to make sure this worked. If the solution is the x value that satisfies the equation or makes the equation true, we should end up with some sort of true statement when we substitute that x value back into the original equation. And indeed, we see that 3 minus 5 is equal to -2, so our answer is x equals 4. Let's look back and see what steps we took to solve this equation. The first thing that we wanted to do was isolate the radical. Isolating the radical allows you to then square both sides of the equation which gets rid of the square root, which is really nice. So then once you've squared both sides of the equation, you solve for x, meaning get x all by itself. And then the final thing you want to do is substitute into the original equation. You'll see why in the next example. And then check for validity. And cross off extraneous solutions. Extraneous solutions, the root word you see in there is extra. They are values that appear to satisfy the equation, but don't really. Let me show you more what that looks like in the next example. Okay, so the first thing we know we need to do is to isolate the root, and that's actually already done for us. The square root is already by itself, so we're ready to square both sides. Over here, the square root and the square cancel each other out. On the right-hand side, we need to use the box method, which you can check for yourselves. Okay, now that we've squared both sides, it's time to solve for x. That's what we'll do next. This is a quadratic equation. Last time we ended up with a linear equation. There were no x squareds in here, so we were just getting x on one side and the numbers on the other. But anytime we're solving a quadratic equation, we want to move all the terms to one side of the equation, get it equal to 0, and then hopefully we'll be able to factor. Two numbers that multiply to 50 and add up to -15. Oh, that'd be -10, -5. So 0 equals x minus 10 times the quantity x minus 5. So one of these factors must be equal to 0. So this is all our solving for x. Now next we need to substitute into the original equation. We'll need to substitute both x values in. So let's start with 10. We have the square root of 10 minus 1 equals, just 10 minus 7. So we have square root of 9 is 3, and that's true. We can check for validity. X equals 10 is the solution. Square root of 9 is 3. 3 is equal to 3. That makes sense. Okay, now let's substitute in 5. We have square root of 5 minus 1 equals 5 minus 7. So square root of 4 is -2. When we're taking the square root and solving a radical equation, we're assuming that we're always getting a positive value. So we have 2 is -2, and when we check that for validity, of course, that's not true. This is an example of an extraneous solution. X cannot be 5 because it does not satisfy the original equation. That's sort of like this process of solving is if you imagine like Santa's pouch of toys, right, which is infinitely large, containing all the numbers in there, like 7 and 49 and -2.3 and 7/8 and negative square root of 5 and pi and all kinds of numbers, right? When you're solving, you're trying to find out which of these infinite number of numbers will satisfy this equation, right? If you're guessing and checking for the original equation, well, you could guess 1, or you could guess 2, or you could guess 3, and just substitute something in. Let's see, is it true that square root of 3 minus 1 equals 3 minus 7? No, because you get negative 4 equals square root of 2. That doesn't make sense, right? You could keep infinitely guessing, but that takes forever. So having a strategy helps you narrow this down by crossing off lots of garbage answers that are never going to come up, but you might get a couple possibilities. Some of them may still be fake outs, and so that's why we need to check anytime you're solving a rational or a radical equation to see if you get any extraneous solutions. That's like you've narrowed it down to just 2 choices in this case, right? We thought 5 was a good option. We thought 10 was a good option. We'd crossed off everything else. But then when you have to go back and check, it turns out 5 doesn't work either. So 10 is the only number out of all the infinite number of numbers that satisfies that equation. Okay, just one more for us today. We know that the first thing we want to do is isolate the root. This time 2 is being multiplied by the root. So to move it, we will divide. So we get square root of x plus 3 is negative 4. Next thing we know we need to do is square both sides so we can get rid of that root. So we get x plus 3 is 16. Next thing we know we need to do is solve for x. This time we just have to subtract. And we'll substitute into the original equation. So we have 2 root 13 plus 3 is negative 8, which is 2 square root of 16 is negative 8. Keep in mind when we're evaluating the square root of 16, we're taking the positive root. And when we check for validity, that's not true, right? 8 is not equal to negative 8. So again, out of all like the many possible infinite numbers of numbers, we didn't guess and check, so we didn't even bother with 17 or negative 5 or 2.9 or e or whatever, right? We didn't have to check all of these. We thought that the only possible number that could solve this equation was 13, but it turns out even 13 is a joke. Even 13 doesn't work, so we conclude there are no solutions. This is the symbol that means no solutions. There is not a single possible x value in the universe that will ever make this equation true.